Again, good afternoon to Algebra 1 students and all lovers of math. I'm going to go ahead and jump to problems 5, 6, 7, and possibly 8 and 9. See how fast this goes. So in problem 5, we have y equals negative 2 times the absolute value of x plus 4. So bear in mind that is also in something very similar to the vertex form, but for absolute values, it's y equals a times the absolute value of x minus h plus k. In this case, there's nothing inside the absolute value bars that we're subtracting or adding, so h equals 0, which means we're not going to move left or right along the x-axis. We're just going to stay at where x equals 0. And then k in this case equals 4, which means we're going to go up 4. So that means our vertex is going to be at x equals 0 and y equals 4. And then negative 2 here, a equals negative 2. That's going to shape our slope, which you can think of as the slant of the line. I always use the analogy of the grade of the road. If you're driving from Reno up to Truckee, where I grew up, or into Tahoe, as you go up the summit, there's a grade or a slant to the road. That's also called a slope. And in this case, it's negative 2, so a better analogy would be driving back down to Reno from Tahoe, let's say, or driving from Truckee down to Sacramento, maybe. Anyway, we now know the vertex. And another thing with the absolute value bar, it's natural. It's called the parent function, but I feel like right on the spur of the moment, I realized, mathematicians should just call this the natural function. But naturally, if h equals 0 and k equals 0 and a equals 1, meaning the slope is just 1, literally, then the trajectory, the shape of the curve for y equals absolute value of x, where there a's there, but it's just 1. It's 1 times absolute value of x minus 0 plus 0. Let me rewrite that. If you had y equal to 1 times absolute value of x minus 0 plus 0, which is also just the same thing as y equals absolute value of x. It's just going to be shaped like a V here, where the vertex is at x equals 0 and y equals 0, or the ordered pair 0, 0. But we have a little manipulation or transformation, which is a big word you guys will hear a lot in geometry. It's shifted or transformed. In this case, up 4 units. So 1, 2, 3, 4. And make that a little easier to see. I wish you could do that on the paper packets or any tasks. Everything is always made so small. Okay, so that's the vertex at 0 and 4. And then because a in this case equals negative 2, a equals negative 2, we're going to erase some of this. we're going to move down. Where am I? Sorry, lost my place here. Number 5. We're going to move down 2 spaces. We're not going to move to the right or left because that's literally just -2/1. It's the rational number -2 divided by 1, -2. So we're going to go down, not up. So that also means when I was talking about the parent function where it's normally shaped like this, because of the slope being negative, going to Sacramento from Tahoe means the curve would be shaped like an upside down V. So we're going to go down 2. So -4, -3, -2, and just over 1. So if I have a table and I had 0 here, and remember the absolute value of x, or 0, the absolute value of 0 is just 0, and 0 times -2 is still 0, plus 4 is 4. So that makes algebraic sense, arithmetic sense, and fits with the geometry of what we did on the graph. Next, 1, when x equals 1, well, if I plug in a 1 for x, the absolute value of 1 is just 1. It's 0, 1, that's 1 space. Or if I went -1, that would also be 1 space. So absolute value is 1. Anyway, absolute value of 1 is 1. 1 times -2, because that's outside the absolute value, so we're not constrained by saying, oh, it's the absolute value. No, it's just -2. -2 times 1 is -2. -2 plus 4 is the same thing as 4 minus 2, which is 2. And that's exactly what we have here, where x equals 1, y equals 2. And we should get the same thing over here, where x equals -1, y should also equal 2. So absolute value of -1 is still just +1, and +1 times -2 is -2 plus 4, which we established equals 2. So also, geometrically, we're doing the same thing. We go down 2 from 4, 2, and over 1. And then let's do this until we hit the x axis, so we have our x-intercept. Next, I'm going to do 2. Well, the absolute value of 2 is 2. 2 times -2 is -4. -4 plus 4 is 0. And if we just went down 2 from 2 and then over 1, we'd end up over there. And go down 2 and over 1, end up over here. Okay, so our little triangle is right over here. And just for kicks, I'm not going to put it in the table, but down 2 over 1, down 2 over 1. Okay. Anyway, what we see, -2, 0. Same thing, if we plug in -2, -2, absolute value of -2 is just +2. +2 times -2 is -4. -4 plus 4 is 0. So that tells us that the two x-intercepts are x equals -2 and 2. The y, I thought I plugged in the inner vertex here. I might have accidentally erased it. So when x equals 0, y equals right at the vertex where the two lines connect. This line over here. Trying to do that in red for extra emphasis. There we go. Well, that red line meets the black line is the vertex. Anyway, x is 0, y is 4. And that's also our y-intercept in this case, where y is 4. So y-intercept, y equals 4. There is no asymptote. There's no line per se that this thing can't cross, at least not a vertical line. Um, the range never goes above 4, however, so we're never going to have a range above 4. Range is starting as we go down, as far down as we can go, which approaches negative infinity. It's going to be, and that's going to be a parentheses there, sorry. Parentheses because you never actually achieve it, or reach it. Negative infinity to 4, and 4 is in brackets because we do reach 4. And domain, we can plug in any real number along the x-axis. And remember, the easiest way I can think of to remember that domain is on the x-axis is that it has the word in it, and a function or a relation is sort of like a machine, or in this case, kind of like a filter, and you put in your x's, and you come up with a y, or input, and come out with an output. So anything that you put in as an input is on this horizontal line. And I don't know how helpful this is, but a domain is also like a domain name, like google.com, yahoo.com, and so it's as you read from left to right, so that's where you put in the inputs from left to right. And you can put in any input for this, so it's all real numbers. There is no asymptote. And then for increasing, well, this thing is increasing as we go to the left, and think of negative as just a set of directions that says move to the left. Simon says move to the left, and positive, the plus sign, means move to the right. So as we move to the left from 0 to -1, -2, -3, and so on, and we go all the way from there, and if one could start at negative infinity and then start increasing, moving to the right, the outputs, the y values, are going to successfully get larger and larger until we hit 0. So between negative infinity, and again in parentheses because we never reach that target, all the way to 0, the thing is increasing, and then at 0 it's neither increasing nor decreasing, so I have that in parentheses, not a bracket. And then from 0, as we move to the right, the outputs are going down. And then again, in this case, to negative infinity, just because the thing is going down now. It's going towards negative infinity. So we go all the way from negative infinity down here, negative infinity down here, negative infinity, because it's below the y, below on the y-axis, it's going down. Okay, so then that takes us to problem 6. 6, I want to say, is relatively simple. I feel like all 3 of my Algebra 1 classes had a degree of familiarity with y equals mx plus b. Sometimes it was given as the answer when it wasn't. I am confident it was a joke because you guys heard so much about it also in the 8th grade, and it was emphasized so much in our class. But y equals mx plus b, also called the slope-intercept form. This is y equals mx plus b, where, well, y is the output, just a generic term once again. M is -1/3, not x. X is the input, is the number that we could plug in along the x-axis. It's the thing that goes inside the machine, the filter. That's a terrible filter, but the x is what goes in there, but the filter, you can think of it as being kind of slanted. Slant is like a slope that's negative 1/3. So m equals negative 1/3, and b, which is the y-intercept, b equals negative 3. That also means that when the input is 0, the output, y in this case, is negative 3. So that means that if b equals negative 3, which is the y-intercept, we're going to start, and also just make it also clear, in the form of y equals mx plus b, it's the number, also called a constant, like 1, 2, 3, 4, 5, when we talked about natural and whole numbers. So it could be 1/3. You could have 1/3 as a y-intercept, but it's a number without a letter or a variable, some unknown thing attached to it. It's just a number by itself, and it's constant, meaning no matter what, that's going to be the y-intercept. So negative 3, negative 1, negative 2, negative 3, right down here. And again, because the slope is negative 1/3, that means we go down 1 and over 3. So we still move to the right as we move from x equals 0 towards x equals infinity, conceivably, as long as there's not some sort of vertical asymptote that would stop us from doing so. Anyway, as we move to the right, we still move, in this case, 3 units to the right, but we're going to go 1 unit down. So 1 unit down from negative 3 to negative 4, and then over 3. So 1, 2, 3. So it looks like when x equals 3, y equals negative 4. Let's see if that makes sense. If we plug in, let's see, y equals negative 1/3 times 3 minus 3. Well, these 3's cancel each other out. That was one of the basic properties of algebra and arithmetic, that inverse property of inverse multiplication. And when you multiply 1/3 by 3, you just are left with 1. In this case, negative 1. And negative 1 minus 3 is negative 4. And that makes sense. So let's go up, because we're going in the opposite direction. So not to make it counterintuitive, but we went down 1 because we're just like you read from left to right. We are going from 0 to x, but now we're going to kind of reverse engineer this and think, well, where did it come from? So we're going to go up 1 from negative 3 to negative 2, and then over 3 to the left. 1, 2, 3. So that looks like when x equals negative 3, y equals negative 2. So let's plug that in again, just to double check. When y equals, and this video is kind of long, so I think I am going to start on problem 7, kind of provide some food for thought, but I won't finish it. Maybe give someone a chance to try and do the problem on their own if they're struggling with it, and then do a new video on maybe the rest of this. Anyway, release problem 7. Y equals, but let's finish problem 6. Y equals negative 1/3 times, in this case, negative 3. So the 3's cancel each other out, but because it's a negative times a negative, it's going to be positive, and it's minus 3. So it's 1 minus 3. Well, 1 minus 3 is -3 plus 1, which is -2, so that makes sense. And then I didn't really do a table here, but first of all, as we connect at least 3 of these dots, we note, is there any restriction on what we can put into the x's here? What can go in on the x-axis? No, there's really no restriction, so it's all real numbers once again. The range, there's not really a restriction as far as what the output could be either. You can tell that, I think you can tell that this is going to go up. This is going to go down, but there's going to be a point where we have positive values for y. We obviously have a lot of negative numbers for y as well. So the range is also all real numbers. On the vertex, there's just one line here. This is just a linear equation. It's not some kind of curve where you have two things meeting, like with the absolute value, where there was a vertex because you had two lines meet at their vertex. Nothing like that. So none for the vertex. X-intercept. Let's see. The x-intercept would be where we touch the x-axis, and that'll mean plugging in another point up here. Before I do that, let's touch base on the y-intercept. The y-intercept, we already talked about, b equals -3. So y equals -3. X, we could solve algebraically by just going, let's see here. Substitute y for 0. So 0 equals -1/3 x minus 3. And so then we're going to add 3 on both sides. So 3 equals -1/3 x. And then to get the x by itself, we want to get rid of this slope. The coefficient is also what that's called. It's the number part that's being multiplied in this case by the x. We can get rid of that by multiplying it by its reciprocal. Reciprocal would be just taking the fraction and flipping it. So the reciprocal of -1/3, it would be negative, not the negative reciprocal, just the regular reciprocal, is -3, because -3 times -1/3 would just be just 1, because negative times negative is a positive, and 1/3 times 3, the wipe out, and if these are both negative, it just equals 1, which in this case means we have 1x. So we want to multiply both sides by -3, and multiply this by -3. So then that would be 3 times -3 is -9 equals x. So when x equals -9, x equals -9, y equals 0, and we can test that real quick. -1/3 times -9 minus 3. All right, so 3 goes into 3 once, 3 goes into, 9 3 times. And it's going to be, that's a negative times a negative. So it's just 3 minus 3, which equals 0. So the x-intercept is x equals -9. And then asymptote, we don't really have an asymptote here. There's nothing restricting horizontally or vertically. Increasing this thing is, as x gets larger and larger moving to the right, y just keeps going smaller, so there is no increasing. None, which just stat it more or less, but as x goes from negative infinity to positive infinity, y is getting smaller and sort of going towards negative infinity, it's decreasing. But as it goes from, but x here all the way to negative infinity here, f3. I don't know what made up number that would be, but just two little circles. And then this is positive infinity. As we move from negative infinity to positive infinity, each y is decreasing. Okay, so now as food for thought, what you might want to do for problem 7, and this is really cool because, for better or for worse, this is very pertinent to what's going on when we start thinking about exponential functions and logarithmic functions. That has a lot to do with the mathematical modeling that you might hear on the news referring to, the pandemic. So sometimes it could be a happy thing. It could be, someone making money, something that went viral on social media that was a net good. But anyway, without belaboring the point, we talked about this before in another video where I mentioned the zero rule, zero property of exponential functions, but 1/3 to the zero power would just be 1. Anything to the zero power is 1, and then 1 plus 1 is 2. So we know that when x equals 0, we're going to be right at 2 over here. And we also should know that when x equals 1, it's just going to be equal to 1/2. So 1/2 plus 1 is 1.5. So I am going to plug in a little table. When x equals 0, when x equals 0, computer's going a little wobbly on me. Let me try this again. Okay, x and then y. Anyway, it's not really cooperating with me like it should, but x and y and then 0. Okay, y would equal, in this case, 2. And anything to the 1 power is just going to be itself. And then it's plus 1, so that's 1.5. So mixed fraction, you could also put 1.5. And then the next one, well, that's going to be 1/2 squared. And if you're not familiar with what 1/2 squared would look like, let me try black. I don't know if that'll make any difference. 1/2 squared is the same thing as 1 squared over 2 squared. So 1 squared, 1 times 1 just equals 1. 2 times 2 equals 4. 1/4 is the same thing as 0.25, so it's 1.25, or 1 1/4. The computer let me put it there. You might see a pattern. This is just like when I talked to you guys about reading a measuring tape or thinking of it in terms of genealogy, but there's a little pattern here. If we have 1/2 times 1/2 is 1/4, 1/4 times 1/2, half of 1/4 is, and again, that would just be 1 cubed. When we substitute, and then 2 cubed. When we substitute 1/2 for 3 here. 1/2 cubed is the same thing as 1 cubed divided by 2 cubed. 2 times 2 times 2 is 8. So that's 1/8. 1 and 1/8. And then 4. What is 1/2 of 1/8? Because remember, we're just adding 1 each time. So 1/2 of 1/8 would be 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So that'd be 1 over 1/16, or 1 over 16. So 1 and 1/16. And you might see the pattern now. So then ask yourself, is there a number this thing is approaching that it never quite reaches? So is there a horizontal asymptote? And also, what is the range going to be? I'll let you guys think about that, as this video is the longest one so far. So, and also the computer's going wobbly on me, so we'll meet at a later point to finish up the rest of section 13.